Okay, hello everyone. Welcome to Concordia University's ForSpace. This is the next installment in our Closer Look series. Now this is a look behind closed doors and into spaces and projects that you might not know about at Concordia. Now this is a special edition, this event. We're welcoming groups here from Concordia's summer camp programs. I think we've got Bones' group, we've got Taco's group, we've got Calico's group. They've been doing all sorts of different things this morning, and now they're coming into ForSpace to see the closer look of the Building Aerodynamics and Wind Tunnel Lab. Now this is a laboratory that houses a large atmospheric boundary layer wind tunnel. It's only one of its type in Quebec, and they study wind building interactions. And it's also, to help situate you, we are streaming to YouTube, live from Concordia University, and we are located here on unceded Indigenous lands in Tiohtià:ke, Montreal. Now there's a note of caution. We are hosting this as a live streamed event, both from here in ForSpace, but also on location. So things can happen. We can lose video. There's connectivity issues. That's all part of the fun. Just stick with us and we'll make this work. Now, we're welcoming some people joining us either via Zoom and YouTube. So if you have any comments or questions, you could pop those into the chat. We'll do our best to read that out, but we also have some audience here with us today that we really hope we can get some questions from. Okay. Now, it's very much my pleasure to go to the lab. I can see we've got someone in the doorway there. Could I please ask you to introduce yourself?
Yes,
hello.
With pleasure. Good afternoon, everybody. I'm Professor Ted Stasopoulos, and I'm the director of the Building Aerodynamics laboratory that you're going to see in a minute. Okay, this is a laboratory. This is one of the very, very few in Canada and the only one in Quebec that really simulates the natural wind and tries to find out what are the effects of wind on buildings and their environment. This is what we are doing here. Should we now start moving there?
We're going to follow you in inside the lab here. We're in the basement of the EV building.
Okay, that's where we are. Now, this is the atmospheric boundary layer wind tunnel that you see here. And in a few minutes, we're going to turn it on to see the natural wind, how it's going to work here. And what you see, this is a called open return type of tunnel. We take the air from the room and we push it down towards us here, okay? And where you see a model on a turntable, because we cannot change the direction of the tunnel. So if we want to check different wind directions, what we do is we put everything on a turntable that we have here. And of course, we turn the turntable and the wind comes this way, as you can see.
From the end.
And we try to see what is happening on the building and their environments. There is an upstream simulated terrain there to show the roughness of the ground. That's what is happening here. And we have a number of instruments that you are going to see in a minute to describe, to do the measurements and find out what is going on. Okay. Now I'm going to introduce my postdoctoral fellow here. Okay, Murad, who is going to go on and give you some more details about the studies we do, the projects that we carry out, and the instrumentation that is available here.
Thank you, Dr. Stathopoulos.
I'm a postdoc.
Hi, Murad.
I'm the supervisor of the wind tunnel lab. Okay, so thank you so much, Dr. Stathopoulos, for introducing the wind tunnel. And now I will turn the wind tunnel on.
Okay.
You will not feel the wind because you are away. But here, you're going to see us feeling the wind, and you're going to see my hair blowing or my shirt blowing, okay, and so on. The wind speed will be approximately 13 meters per second, and it's equivalent to 35 to 40 kilometers per hour.
That's a big wind. Murad, can you hear me okay?
Yeah. Yes, I can hear you. I will turn on the wind now.
Okay, he's going to turn on the wind. I'm just going to stand away. Go for it. Okay. I think we've got the noise reduction on Zoom there. So the wind's coming from the end of that tunnel. It's blowing across these models. And you guys can't hear anything because it's so loud in there. My colleague Bertie is doing their best to survive this end of this wind tunnel. Bertie, I don't know if you can hear us. I don't know if you could turn off the noise reduction on Zoom so we could hear it, but we're we're not getting the sound through. But I could tell you that it's actually it's quite loud. Maybe you don't even need to hear it.
So as you can see here in the wind tunnel, we have a small house which is as a model, okay, that represents a house in the full scale. So we bought this house inside the wind tunnel to measure the wind loads on it, okay, using the pressure scanners that are located underneath the wind tunnel, okay. There's no more, yeah, they are located underneath the wind tunnel. We have a pressure scanners, and the model is connected with the pressure scanners using tiny pipes, okay. This will take the signal to the pressure scanners, and we can have the pressures displayed on a computer, okay, in the lab here.
Right,
Oh, hold on, maybe. Yes, Doug, do you want to just react to that? Do you have any questions or anything?
I just wanted to take a little minute because it maybe isn't super obvious from here that there's a model of a house, and that house has sensors embedded into it that pick up not just the wind pressure, but what's happening because of the shape of the building, that's like the model itself, but also the smaller models at the end there.
Yeah, Murad, maybe can you elaborate a little bit, like the difference between this small box that we're seeing that's enclosed and then all the little tiny boxes that we're seeing back here? Yeah,
sure. For the small model that is near to us here, the plexiglass model, it is the targeted model, okay? The model that we want to calculate the wind loads on, okay? Yeah. So this is a representation of a real house, okay, in reality. Now for the tiny foam cubes in the upstream, they are a representation of a city exposure. Okay, so if we want to simulate a city, we put these small foams, okay, small foam cubes to represent several buildings within the city. For another example, okay, is an open country exposure where we will remove all the roughness elements, the small foam cubes, and keep the carpet to represent an open area, like an area in the airport.
Right. So this one. So I'll just say that again. We have the small models at the end. That's kind of giving a cityscape. So when the wind comes down, it gives some more turbulence to the wind itself before it hits our main model house. Okay. But you have there are other models as well. Is that true, Murad?
Yes, of course. We will see them all now. Yeah, right, let's go that way.
Let's go.
Okay. Yeah, plenty of medals. Yeah.
Oh, who do we have here?
We start with models with different colors. The colors doesn't mean a difference between the model here and the model there, okay? Yeah. So it's only the material we made the model from. So these are other models for other objectives, okay? Yep. And they have different sizes. Also, we have another model here. This model was created to calculate the wind loads on canopies. On a
canopy.
Okay, and yes.
So these are all connected to these tiny little sensors that almost look like straws coming out of the back.
Yes, of course. I can show it to you here, okay? So we can, I will take another more obvious model. So okay, this is another model that shows we call them spaghetti, tiny pipes, okay? We call them spaghetti. Yeah. They are connected to the pressure taps. Here, they are tiny holes, and these tiny pipes are connected to pressure scanners at the end. When we put them in the wind tunnel, we connect them to pressure scanners that measure the pressures.
Pressure sensors at the end of each of those tubes to get multiple readings across the surface of the buildings. Okay.
Exactly.
Incredible.
Yeah. Now, right now, okay, I will leave you with a PhD student here. His name is Sakib, and he worked on this model, the model with the canopy. So I will give him 2 minutes to explain and to introduce his model.
2 minutes. Let's go.
Everyone. Hello,
Hello.
everyone. I'm a PhD student right now, but this model is for my master's. We finished it. This is the canopy, and our project was to find out the wind load on a canopy. These are actually important because wind load plays a very important role for these things. Let's say there is a very strong wind and something got broke here, and then it will actually hit a pedestrian. So some people, without any knowledge, they may be hurt. So that's why this was actually important. So we tried to figure out the relation between the height of the building and the height of the canopy from the ground. And we actually tested 3 different buildings, like a small building, a building that is a little bit longer, and a very high-rise building. And we actually placed this canopy into various places so that we have a good amount of data. And we try to analyze the data and try to give results that designers can use to design this safely. And our results was adopted by the ASC 722 and NBCC 2025. So you can see the wind loads for canopies actually came from this study, from this lab.
From there.
So let me just clarify, I think. Does that mean that the results that you took from these experiments directly affected the building codes?
Yeah, you can say it actually, it got adopted by the code, and it affected the building code.
All right. Amazing. That's
Very
amazing.
cool.
Bertie, are we moving on to another step? Do we have another thing to see?
Yes, we do. We've got lots more to see. I'll hand you back to Murad here.
Okay, thank you.
So indeed, okay, the radars, okay, obtained from this wind tunnel are adopted by the Canadian Building Code and also the American standards. Okay, it's not only in Canada; it's in USA. Huh?
Great.
So we have other buildings here. This is a representation of solar panel model. Okay, so you can see that we have here a simulation or a scaled down models, okay, of solar panels. Okay, this is a representation of solar panels.
That's to try to see the wind, how the wind is affected, how the solar panels are affected by wind pressure, to make sure they stay on the building, to make sure they're not, right? Yeah.
And here you can see other models, okay? Models with gable roofs,
Yep.
models with flat roofs. And yes, these all were tested in the wind tunnel, and the wind loads were quantified on such buildings.
Incredible. Different buildings, all different types, all different ways of seeing how the wind reacts to different shapes, different sizes. And all of them can be connected with your spaghetti.
Yes, you are right.
Thank you. Okay, we're following you around. Oh, what do we got
now
here?
we have done from the research model, the models that were created to quantify wind loads on general buildings, okay?
Yes.
On the other side of the wind tunnel, we have commercial buildings.
So those were we saw the test models to see generally what happens to kind of average types of buildings, but now they also test specific building projects to see what happens.
So you're
Go ahead.
seeing the back end of the wind tunnel here, just so you know. So this is where the wind is coming from, I guess. Is that right?
Yes, this is the fan. And
Amazing.
This is, a big model, a big motor, sorry, and it rotates a fan, and you can see the fan from the other side, okay, because we have a screen here.
Amazing.
So it's a big fan, and when it rotates, it generates wind, okay?
You're right. This is the
Here we
model.
have
It's a part of
up and down.
Montreal, I think. Anybody recognize it?
Yeah, you are right. This is the La Fontaine Tunnel in Montreal.
La Fontaine Tunnel. Okay.
And yeah, now it was a project to study whether they wanted to install solar panels in the La Fontaine Tunnel, and they wanted to study whether the snow would be drifted, okay, to cover the solar
Oh, I think we're losing you again, team.
So we have another model there. Okay?
This is one I
model
recognize.
in downtown Montreal.
Yes. I recognize some of those buildings.
So-
I think I can see Place Ville Marie there with the cross shape.
So can you see the René Lévesque?
Yes.
We have also Rue Alexandre.
So Murad, you can put these models into the wind tunnel.
This model was for
They all lift up.
pedestrian wind study.
Yeah.
Sorry, Murad, I'll just let, Doug's asking, so you guys actually put these models in the wind
Yeah,
tunnel?
in the wind tunnel, yes.
So in the place of the little boxes that we saw at the back end, you would place something like this?
The small box, okay, the front small box.
at the
Okay,
front.
At the
On the
turntable.
turntable.
On the turntable.
So we put this model there, okay, to measure, okay, how the wooden model inside here,
Yeah.
this building was not constructed. The study was about, okay, seeing the effect of building that model, okay, on the pedestrian wind.
So we're moving through, I just wanted to
we're
get us out
moving
of that
quickly.
dead corner.
Yeah.
So we're
This is
looking
the
at some of the
Montreal.
others.
That's good. I love these models. Murad, these are all different models made by different researchers at different times, I suppose. I see the liking.
Yes, exactly. Okay, so that model, okay, the last one you saw, okay, I wasn't here when it was constructed and tested. So I'm giving you just a general idea of what that model was built for.
Yeah.
Okay.
Oh,
And we've got another one here.
Yeah, I think now.
does anybody here recognize where we're looking at here? That's
Yes.
a pretty, you might have seen this building before. It's at the McGill campus. That's the medical library, right? I think that's right.
Yeah, the medical. Yeah, this is the medical building, and this, if you can see my finger, I'm pointing to the biology building in McGill.
Okay.
And behind this two buildings is the Montreal, as
Park
you know.
Montreal. Yeah. Okay. And what did you use this model for, Murad? What does? Okay. We're moving on.
Yes. Now, at a certain time, okay, in the past, okay, in McGill, they had some students, okay, that get sick, okay,
Yeah.
get fainted.
People were getting sick in the building.
Area when they go to the cavity, okay, they get sick and they get fainted, okay, and
Feeling faint.
they wanted to know what was the reason for them to get sick, and they found out that the toxic gases, okay, that comes from the medical building and the biology building are circulated by the wind, and they are input again inside the building. Okay,
Exhaust from the front building was going
that's
into
why-
the library. Okay.
Yes.
So you were able to see that by putting the model into the wind tunnel. You could see that there was a circulation from one building into the other.
Yes, exactly. Okay, this is what they
Wow,
confirmed
that's
at the
wild.
wind tunnel. Okay, they have seen that whatever toxic gases comes from the buildings, they will be circulated by the wind when the wind blows from the Montreal. Okay, and they will import again inside the buildings. And this is okay. That was the reason for the sickness and the problems that happens for the students.
Yeah.
And the reason or the solution that was suggested for such a problem was to put some filters at the windows of the medical building, and that was how the problem solved.
So you're able to go from like that, identifying that problem to quickly finding a possible solution so that people weren't feeling terrible inside that building any longer. That's pretty wild.
Exactly.
This is another model here where.
Yeah, I have a question for you, Murad. I can see that the models are all sort of made out of different materials. Like some of them are styrofoam, but this one that we're looking at here is mostly wooden.
Yeah.
Does that affect anything is there a choice to be made there, or
Right.
why the different materials?
The materials doesn't matter here because we are dealing with the buildings as rigid models. Okay.
Okay.
We are not targeting elastic models. Therefore, okay, the material is a choice of the designer of the model. Okay. It doesn't make a difference when we are conducting the test inside the wind tunnel. Yeah, sure, yeah.
Oh, look at this. This is a good view inside of the city model. that's on the floor of the wind tunnel. Team, should we,
Go ahead, Doug.
yeah, I was just going to see, if are we maybe going to go back around to the front of the wind tunnel and see if we can get any questions here from our group?
Yeah, sure. Yeah.
Does that
Let's
make
do
sense?
it.
Yeah, let's do it. So we've seen a lot of different models. We've seen a wind tunnel. We did see you when you turned on the wind tunnel. We saw it happen. We couldn't hear the sound, but I can justify or remember that it's quite loud. Look at all this. Does anybody here in the audience have any questions about this wind tunnel? What's happening in this lab? I see one here. Murad, are you okay to take a question?
Yes, of course. Yeah. It would be my pleasure to answer questions.
Just wait till you get into the camera here so we can see. There we go. Okay.
Do the models that are put into the wind tunnel, especially the smaller ones, do they ever get blown over?
Yeah, this is a very good question. Yeah, sometimes they are blown over, and what we do is we take them back and put them again, stick them with the glue.
Oh, model glue.
Yeah,
Or
yeah, you are
glue.
right. Yeah, this is a very good observation.
Yeah. Okay, we have another question here.
How long does it take to make a model?
Oh, yeah, it depends on the model itself, okay? Sometimes, okay, it takes a month to make a model, and sometimes it takes 1 day. It depends on the target of the model. If we want to measure all the wind pressures all over the building, okay, we have to make several tiny holes within the model, several sensors, and this takes time.
More sensors, more spaghetti,
Yeah.
more time.
Yes, exactly.
That makes sense.
I think we have another question over here.
Yeah. Hello. I was
Yes.
gonna ask that, like, so when you're building like the wind tunnel over there, like, I was gonna ask how did you build this? Like, yeah.
Oh, the wind tunnel itself.
The wind tunnel itself, how did that get made? Maybe that was like Dr. Stathopoulos was at the beginning. He probably maybe knows how it was built. But Murad, what do you think? Do you know much about the construction of this wind tunnel? Apparently, Quebec.
I don't know a lot, but I know it was built 46 years ago.
46
okay,
years
so
ago.
1980. Okay, they started it. Okay, and they completed it in 1984.
So
And yes,
Oh, camera's running.
and you now can see that we are doing maintenance for the wind tunnel, and the maintenance is dated back to 1987. You can see a very old piece
Whoa,
of paper
look
there,
at this.
and it
Thank you, Jack, for
is
running.
dated back to 1987. And you can see that the maintenance is continuous, and we have done maintenance recently in 2023 and 2024.
Okay. And Murad, there's another wind tunnel in Ontario, in London, Ontario, maybe at University Western? Is that the
Yes,
other one?
You are right.
Yeah, I remember that. Okay. Do we have any other
University.
questions here? I saw maybe there was a hand. No? Yeah? No? Okay.
Sorry?
I'm just looking to see if we
I
have
think
any
you guys
other.
can see
any other- there's got a
right
question
now, because
here.
Jax is kind of showing you alongside the tunnel. Like the tunnel's actually like quite big. It's the
Yeah,
whole
this is great.
length of this room.
Yeah.
And then there's these levers along the side that some of them, it looks like they open up, and so there's like windows that you can see in. We're going to be coming up across one window just like right now. So you guys can kind of see how
See
sometimes
it,
there's
yeah.
windows along the side,
And
so you
some-
can get a better look at what's happening.
And I think sometimes you blow smoke and different material through the tunnel to
Yes.
see more
Yes, you're
easily
right.
what
We have
the
smoke
wind is
generators
doing.
here in the wind tunnel,
Yeah.
and whenever we want to visualize the wind, see the wind how it moves around buildings, we use the smoke generators in order to do so, to visualize the wind. Because when the smoke is moving, okay, we can see the trace of the wind,
course.
how the
Yeah.
wind is moving.
Right, becomes
But
visible.
the wind without the smoke is transparent. We can see it, of course.
You can see it.
Of course.
We have a couple other questions here. Can we take a couple questions? Okay.
What are the spaghettis for?
We wanted to remind us of what the spaghetti sensors were for.
Yeah, these were for measuring the pressures.
Measuring the
Measuring the
pressure.
pressure. Sure, at
Yes,
certain
so
points.
yeah.
Okay. Thank you. We have another
So the
question
spaghetti
here.
sound like that's like how fast the wind is going? Is that what you mean by pressure?
No, it takes the aeronautical pressure signals from the top of the model to the pressure scanners and it gives you how much pressure wind pressure we have at that specific point.
Okay, so how much of the wind is like bearing
Yes.
down?
Okay. We have another question right here.
How many models are you currently working on?
This is a very good question. Actually, right now I'm working on two models, The model that you are seeing here and a city model of downtown Montreal.
Team, I'm seeing a few more questions here in the space. If we could handle a couple more, are we good? I know we're taking up some of your time, Murad, but there's some interest here in what's
No, it's
happening.
okay. I'm very glad to answer the questions.
Okay,
Yeah.
great.
How big does the motor need to be to turn the fan?
Did you hear that one okay?
See how
Size of the motor.
Yeah, it's big. You can go there. We can go there and see
We're gonna go back.
the motor. It's the blue motor.
The motor that drives the blades of the fan. Our
So
other team member
it
Jax is on the cameras
huge,
today.
And I'm gonna explain how
running
the
around.
fan is moving.
Try and show us.
So we have this big motor, and it is connected
Okay.
with some belts, and these belts are connected to the fan. So once the motor is
yeah.
rotating, the fan is rotating, and this is how the wind is blown.
How did you
So
decide on this size of a
the-
motor? That's just the biggest one you could fit in the room, maybe.
Sorry?
How did you decide on what size to use?
Well, actually, this was decided by Professor Satopoulos when they designed the wind tunnel.
Yeah.
So they decided that this motor is enough to generate the required wind for wind tunnel testing.
Okay.
All right. Can we have another question. Are we good? Okay.
What made you decide the color of the wind tunnel?
Come again?
The question was about the color. You mean about the wood? Like there's wood, and then there's like the carpet, and then there's the paint of which color are you interested in?
Why did they make the wind tunnel blue?
Ah, the motor. Why is it blue? Did it just come that way? That's the
motor,
yeah.
I think,
It came with the blue.
yeah, the manufacturer
all you
was giving or producing blue motors.
Yeah.
That's why it was blue.
I think we've got time for one last question here, and then we'll say goodbye. But I'm going to just pass it over here for one more.
Did you ever test the wind tunnel boats on the Fleuve Saint Laurent?
You're asking if you've ever tested boats? Yeah. Have you ever tested any boats or other vehicles, maybe?
But I didn't hear it.
Okay, just one sec. We didn't hear it. Can you repeat your question?
I'll just yeah. Can you say it again?
Did you ever test it on boats and rivers, in the rivers of Montreal?
We're curious if
you
you've ever
test it on
tested boats, a boat, or maybe even other vehicles, things like that, other than buildings.
No, the boats were not tested here. No.
The buildings,
We don't have a
typically
model
buildings.
for boats.
Yeah.
Just buildings.
Amazing.
Are there any other questions?
I think that's good. I think we've got. I think that we're good. I think Murad, I'm going to say first of
Maybe-
all, Sorry, Bertie. Do you have a? Go ahead.
Yeah, maybe we could just turn on the wind one more time,
Yeah, exactly.
and then you can say goodbye to us as we blow away on this side.
Yeah,
Hey,
sure.
Birdie.
So we have here.
Hey, Birdie, before you do that, I don't know if you can hear me.
I've adjusted it. Don't worry, Doug.
Okay,
2,
thanks.
1, go.
Oh yeah, there we go. There we go. All right, that's our farewell, I think. Murad, thank you so much. Thank you, Dr. Stathopoulos, as well as Agib. Thank you for all three of you for showing us around. I think we've blown our camera out there. We've saying goodbye. And also, of course, thanks to you guys and your questions. Those were really great questions. Unbelievable. Okay, we're going to wrap up the Zoom and the live stream. Those of you joining us on Zoom as well, thank you for joining us. This remains available on our YouTube channel. You can check it out there. And you should all have a wonderful afternoon. Thanks, everyone. Woo. Bye-bye. Woohoo!
Okay.